Greetings, this is Steve MacKenzie, former 20-year member of the Visual C++ team at Microsoft, now retired. And I want to share my GitHub repository, in particular one project called RaspLibs. It is a sort routine written in ARM assembly that will run on a Raspberry Pi that you can develop, self-host, compile on a Raspberry Pi. And so you can enlist into this repository at stevemac321/RaspLibs, on GitHub. Full URL, github.com/stevemac321/RaspLibs. And so let's take a look at the code. So on the right pane here, I have lots of comments so you can understand how it works. I recommend, though, that you write your own insertion sort or your favorite sort routine and then work it through. And you want to use pointer syntax and not index syntax. And so on the left here is the driver code with the test harness and everything. And we sort all different types. We sort integers, we sort a grid of integers, and we sort strings. And the reason we can sort all these different types is because they're all the same size if they're the same size as a pointer. And so I have a work item we'll talk about later on how to be a little more versatile than that. So that's the test driver code. And also you notice that I have these macros that do the comparisons and so on. And so another work item would be to port this over to Google Test, which is supported on Raspberry Pi. Okay, so here's the sort routine with the directives here at the top. And I believe that this will work on in a IAR embedded workbench environment as well. I have a version of that checked in also on my GitHub repository. This explains the high-level algorithm. Here's some functors, but I have a much richer library of functors in the library itself. And then here's the generic sort routine with the outer loop and an inner loop. And I have really good explanations on how it works, and especially on how you walk the array, how to shift to walk the array. And yeah, and so I kind of give you the step-by-step explanation. So that's the code you can look at. And so let's go ahead and run it. So it's built already, and so we're using, we're using GCC, and so it runs on ARM. We're not doing any cross compiling or anything. So there we go. I probably can update it. This is a couple of years old now. So what do I have in here? I have a make file, so you can just run make and it'll build it, and then you can run it. And so there you go. Here's the results. So here's a single array, and I use a random number generator, to create these arrays. Some of them are hard coded, like the strings and so on. But and so we are sorting the strings in lexical order, like in a dictionary, for example, lexicon. Again, so that's it. Let's go back to the GitHub repository and go over the work items. So this is open source, so you can help out. So add a size parameter to the sort routine. Like in qsort, you can specify the data size. So instead of just shifting the array the size of a pointer, which I believe is 32 bits in the way that I'm running it, you can shift by the size of the array. So you can do like chars, which are probably smaller, and other data sizes. And then port the framework to Google Test. See, I think that is about it. So Please don't be afraid to contribute and give back your changes. So I think I can end the video now. And so thanks for your attention.